Have you ever looked up at the vast expanse of the night sky and wondered if anyone out there is trying to contact us? For decades, humanity has cast its senses out into the cosmos, listening for a whisper, a sign that we are not alone. But what if I told you that some whispers have already been caught, strange whispers that defy easy explanation, hinting at mysteries far beyond our understanding? Imagine this. A burst of energy, impossibly powerful, lasting only milliseconds, originating from a galaxy billions of light years away, or a signal so unique, so perfectly aligned to what we imagine an intelligent alien message might look like, that it leaves astronomers speechless. These aren't science fiction. These are real signals from the depths of space that have left scientists asking one tantalizing question: what are they hiding? What secrets are embedded within these cosmic whispers? Tonight, we delve into the most mysterious signals ever detected from deep space, signals that might just rewrite our place in the universe. Welcome, curious minds, to a journey into the heart of cosmic enigmas. For as long as we've had the tools to listen, we've pointed our telescopes toward the stars, hoping to answer one of humanity's oldest questions: are we alone? The search for extraterrestrial intelligence, or SETI, has been a beacon of hope for some, a fanciful dream for others. We've received countless blips and beeps from the cosmos, most of them explainable as natural phenomena, the predictable hum of pulsars, the dying breaths of distant stars, or even interference from our own noisy planet. But amongst the cosmic static, there are anomalies, signals that stand out, defying easy categorization, and hinting at something more. Tonight, we're not just talking about random noise. We're exploring specific instances that have puzzled scientists and ignited the imaginations of millions. What are these whispers from the void, and could they be messages from civilizations far beyond our own? One of the most famous and perhaps most tantalizing of these cosmic riddles is the legendary WOW signal. Picture this: August 15th, 1977. Astronomer Jerry Eman is poring over printouts from Ohio State University's Big Ear radio telescope. Suddenly, his pen circles a string of characters on the page, a sequence so striking, so unlike anything normally detected, that he scrawls "WOW" in the margin. This wasn't just a blip, it was a powerful, narrow-band signal that lasted for 72 seconds, at a frequency remarkably close to the hydrogen line, a frequency often theorized as a likely channel for interstellar communication, a kind of universal dialing tone. The signal was strong, 30 times louder than the background noise of the cosmos, and it appeared to come from the direction of the constellation Sagittarius, near a star group called Chi Sagittarii. What made the WOW signal so compelling was its profile. It matched, almost perfectly, what scientists predicted an artificial extraterrestrial signal might look like. It rose and fell in intensity exactly as the Big Ear's antenna swept across that patch of sky, indicating a fixed point of origin beyond our solar system. Despite countless attempts over the years with more advanced telescopes, the WOW signal has never been detected again from that region of space, or anywhere else. It remains a ghost in the machine, a fleeting moment of profound mystery. Various explanations have been proposed, from transmissions bouncing off space debris to, more recently, hydrogen clouds from comets. However, many of these explanations don't fully satisfy all the characteristics of the original signal, particularly its strength and narrowband nature. It remains an unsolved puzzle, a 72-second whisper from the stars that continues to echo through the halls of astronomy. What was it? A fluke? A natural phenomenon we don't yet understand? Or was it, just possibly, a greeting from across the cosmic ocean? But the WOW signal isn't the only enigma that has astronomers scratching their heads. In more recent years, a new cosmic puzzle has emerged, one that is arguably even more powerful and more baffling: fast radio bursts, or FRBs. Imagine an explosion of radio waves, so intense it outshines entire galaxies for a few milliseconds, then vanishes without a trace. These aren't whispers, these are cosmic shouts, and they're coming from incredibly distant galaxies, billions of light years away. First detected in 2007, though the data was from 2001, these FRBs were initially met with skepticism. Were they instrumental glitches, terrestrial interference? But as more were detected by different telescopes around the world, their astrophysical reality became undeniable. The mystery, however, only deepened. What could generate such immense power in such a short timescale? Theories abound, ranging from the cataclysmic collisions of neutron stars or black holes to the energetic outbursts of highly magnetized neutron stars called magnetars. And then there are the more exotic possibilities. Could FRBs be evidence of advanced alien technology? Perhaps the energy signature of massive spacecraft propulsion systems, or even beacons deliberately constructed by a civilization far more advanced than our own. The intrigue intensified with the discovery of repeating FRBs, like the famous FRB 121102, which has been observed to burst multiple times from the same location in a dwarf galaxy over 3 billion light-years away. Repeating signals are harder to explain by one-off cataclysmic events, though some models involving magnetars can account for repetition. Still, the sheer energy involved and the precise mechanisms remain subjects of intense research and debate. Each new FRB detected adds another piece to a puzzle that could revolutionize our understanding of the universe's most extreme physics, or perhaps something even more profound. Beyond these headliners, other signals have briefly piqued interest. There was SHGB02+14a, a radio source identified in 2003 by the SETI at Home project, which exhibited some characteristics that made it a candidate for further study, though it too has not been redetected with the same significance. And who can forget the buzz around KIC 846282, or Tabby Star, whose unusual and dramatic dips in brightness led to widespread speculation about alien megastructures, like a Dyson swarm harvesting its energy. While not a radio signal, the strange data from Tabby Star highlights our eagerness to find patterns and consider extraordinary explanations when faced with cosmic anomalies. Though natural explanations like dust clouds are now favored for Tabby Star, the episode showed how quickly the scientific community and the public can become captivated by the possibility of something else out there. Interpreting these whispers from the cosmos is an incredibly challenging task. The universe is a noisy place, filled with natural radio emissions from stars, quasars, pulsars, and interstellar gas. Differentiating a potential artificial signal from this cacophony requires sophisticated technology and a deep understanding of astrophysics. A signal needs to exhibit certain characteristics to be considered a serious candidate for extraterrestrial intelligence. It should ideally be narrow-band, meaning it's confined to a small range of frequencies, unlike most broad-spectrum natural emissions. It might contain patterns, repetitions, or mathematical sequences that are unlikely to occur naturally. And crucially, it needs to be verifiable, detected by multiple observers or at multiple times. The famous Drake equation, developed by astronomer Frank Drake, attempts to estimate the number of active communicative extraterrestrial civilizations in our Milky Way galaxy. While many of its variables are still highly uncertain, it serves as a framework for thinking about the probabilities involved, and reminds us that even if civilizations are rare, the sheer size of the galaxy could still mean we are not alone. The search, of course, continues with ever-increasing fervor and technological prowess. New generations of radio telescopes, like the square-kilometer array currently under construction, promise to scan the skies with unprecedented sensitivity and scope. Artificial intelligence is being deployed to sift through a tsunami of data, looking for those faint, anomalous signals that human eyes and ears might miss. We are peering deeper into the cosmic darkness, listening more intently than ever before. Each strange signal, even if it ultimately proves to be natural, teaches us more about the universe we inhabit. And with every null result, the silence itself becomes more profound, making the question, "Are we alone?" even more poignant. So what are these mysterious signals hiding? Are they simply the universe showing off its complex and often bizarre natural processes? Or are they fleeting hints, cosmic breadcrumbs leading us towards an encounter that would change humanity forever? The truth is, we don't know yet, but the quest to find out is one of the most exciting and fundamental scientific endeavors of our time. These whispers from deep space remind us that there is still so much to discover, so much to understand. They ignite our curiosity, fuel our imagination, and challenge us to keep looking up, to keep listening, and to remain open to the possibility that someday one of those whispers might just be a clear, unmistakable hello from across the stars. What would it mean for us, for our philosophies, our religions, our very understanding of life, if we confirmed we are not the only thinking beings in this vast cosmos? The implications are staggering. The search continues.